Hello, Colin. Fun one today. I had a customer reach out to me about a pair of QFX 5200s they have set up in an MC lag pair. They were asking about upgrade options, and they came across this interesting document that covered a procedure that I'm not familiar with. Well, I should say I'm familiar with what it is. I just didn't know it was called this. It's TISSU. Now, in this case, the T stands for topology independent, and then the ISSU is the same term that we would use for any other upgrade with the dual RE system. That's in-service software upgrade. ISSU takes this concept of ISSU and applies it to Linux-based systems that run a VM host and then Junos as a guest on top of that VM host. On these platforms, which include the QFX 5100s and the QFX 5200s, we can actually run two different VMs that are both running Junos. And that's kind of like having two REs. You're probably starting to understand where I'm going with this. So let me show you the documentation for TISSU, and then I'll show you the lab that I have built, and we'll walk through the upgrade process. And I've got some other devices that are connected so that we can see what it does with protocols, and we can track host-to-host traffic that crosses this switch. Alrighty. So on the screen right here is the topology independent in-service software upgrade. Now you notice this says QFX 5100. I'm dealing with QFX 5200s. And that is an important distinction to make because you got to go check compatibility. Now, TISSU itself is not something you're going to find in our Feature Explorer. It's just a way of doing an ISSU upgrade on a platform that supports the TISSU process. Essentially doing in-service upgrades on a single box that doesn't have two REs, but does have two guest OSs running on top of the host system so that you can basically upgrade one, fail over, upgrade the other. So before you even start this process, you're going to want to check, let's see, Feature Explorer. You're going to want to check to make sure that ISSU is covered on your platform and that you've got the right code. And it's interesting, this is going to bring us to the first, oh, I went to the wrong place here, to the first problem I ran into. This is the parent, okay. And that is, you can see over here, whoops. Support, if you look on this page for QFX 5100, started way back out 2013, but support for the 5200 is 19.2. Now it's a whoops for me because I initially thought this was going to work on my customers' QFX 5200s. They're running in the 18.x code train. So my first step here is going to be to upgrade my QFXs just using the normal procedure to the supported code for ISSU. And then I'll upgrade from there to the recommended code that's in the 20.2 train. So there'll be two upgrades, and it'll actually allow us to compare how non-ISSU versus ISSU performance and network impact looks. So let's get started, and I'm going to use a stopwatch. I'm going to pause during the upgrades so you don't have to sit through them, and then we can just look at the packet loss. So let me walk you through the lab itself, and we'll get to it. Now, I'm not using Eve for this lab, but Eve does give me a nice little way to show the topology that I have. All of these devices here are physical, and they're sitting in the room behind me, and maybe I'll splice in some video of what they look like. I've got a couple Raspberry Pis plugged into a couple EX4300 switches that are then connected to a pair of QFX 5200 32Cs. These devices are all configured already, and essentially I've got this device pairing with that device. They've got OSPF running between them for loopback advertisement, and then I've got eBGP running between them and advertising to some dummy prefixes that I have set up. There is no L3 for these hosts. They're on the same subnet. The reason for that is my customer use case. In their environment, these QFXs are straight layer 2 devices. The only layer 3 they have is for management and for the MC lag, keep alive stuff. If you ever are wondering the difference between, I call it ISSU, we call it Unified In-Service Software Upgrade, so UISSU sometimes. NSSU is Nonstop System Upgrade. That really only applies to virtual chassis systems, or I think it's the same term if you have a virtual chassis fabric, VCF, and it just allows an administrator to put the code on one box the routing master, the RE, and run the one command and then upgrade everything. There's still, you take hits, there's outages, because all these devices, when they are doing an upgrade, they are going to bounce because they don't have dual REs, and these EXs that are in these VCs don't have a dual guests running on top of a hypervisor host. But if you've got links that are aggregated across them in lags, then the lag will degrade, but the links will stay up. I think conceptually that's what you're going for. All right, so L2 only on the 5200s. The routers are my EX4300s. Let's take a look at those real quick here. So here's EX SW1. I'm using AE54 and AE22 for my links. AE54 goes to this switch up here, and AE122 goes down here. I'm kind of using, for the most part, the configuration that my customer sent me, and these are the AEs that they're interested in, but these could be anything. This is just for the purpose of this test. And then the VLANs we're interested in here, we have a storage VLAN, 450, and we have a peering. This is basically the router VLAN 1099. So if we go to this switch and we do a show BGP summary, we'll see that we have our peer. This is the peer to SW2, and we can do a show OSPF neighbor, and we've got a full neighbor relationship. So these are the protocols that we're going to keep an eye on while we do the upgrade. And these are both going over lag interfaces. So I can do a show, let's say interfaces AE54. We'll see that that is up and running. And if I do 122 on this box, it won't show it because that is on this device. Switch 2. So there we go. Now, these are the switches. They don't, these are, pardon me, the EX routers. They don't have any clue that MC lag is being used. This is one of the two QFXs, and here we can verify our MC lag by doing a show interfaces MCAE ID 54. This will show us that we have our link that goes to our EX router switch 1 up, and then we can run the same command against the AE122 that goes to the EX router switch 2. We could look at this interface. I do a show ICCP. It shows me that the inter-chassis control protocol is up and running between the two devices. There's some other things. I can ping between the hosts. Just trust me that those are pinging each other. I've tested all this already. So these are my pies up here. They're numbered pi 5 and 6 because I have pies that are already numbered, so I didn't bother renumbering them. But everything can reach everything else. This pi can ping, what's it, 168.168.1. That's the remote side. Actually, I just realized I need to update that. 168. The elements that you need for TISSU to work on a box that supports ISSU are these. You need to enable graceful switchover, nonstop routing, and nonstop bridging. And that would be on both of the MC lag devices. And if you go back to the instructions here, that actually shows you right here what you need to set up. And this commit synchronize as well. And I have commit synchronize. So all this is ready to go. We're not going to spend any more time on that. So let's start our upgrade. The peering is already up, so we'll keep an active eye on that. And to test, basically monitor the host connectivity, I'm going to use a tool called MC Join, which is a really nice multicast monitoring tool that also has a really nice almost smoke ping output. So that will allow us to have a real-time view. I'm also going to set up a stopwatch here. You can see that here, and I'll switch it to windowed mode. It should be fairly quick because even though we're upgrading, since we're running MC lag is the whole point, but I do expect there to be some convergence here. So let's, and again, this is, TISSU isn't an MC lag thing, just so we're clear. This is, I'm using MC lag here because this is what my customer asked me to use. TISSU is meant to allow you to upgrade a single box that is in a data path with very, very just absolutely hardly any packet loss or protocol convergence or anything like that. This is all self-contained. I'm just using MC lag as an example. So I'm going to run MC join here. This is the listener. And just to show you how this works, I can start this client on this side. and you'll see that it will track the number of packets. And all right, we're off to the races. So let's start our upgrade, and I'll start by upgrading the active device. So we'll do request system software add. Let's see, bar temp installation. And don't do the reboot. And I'm going to do no validate because I know I don't have any syntax issues that I need to worry about here. So let's run it. We won't have an interruption here because it's going to be staging, because I didn't do reboot at the end of this command. So I'll go ahead and pause the video. And once we do the reboot, that's when we're going to, if there's going to be an issue, that's when we'll see it. All right, we're all staged. System reboot. I guess we're waiting a minute. I won't make you sit through it. All right, so I'll be tracking the amount of time it takes for the entire upgrade for this one device to run here. And in the meantime, we will track this. And it seems like it's pretty close. And we'll also keep an eye on our peers. Summary. We'll see if this number here for flaps actually changes. And we'll also see this up-down value change as well. So we'll do this, click up, refresh every, let's say 5 seconds, be fine. And then jump over to this device and watch this restart. And this is less persistent, so we're just going to keep an eye on this to see if we lose any packets. We'll get a sense of that at the end. I can hear this box rebooting in the background. You might be able to hear it now too. So if we were going to lose something, we would have lost it by now. Let's see if this flapped. And it shouldn't. I want to be clear that if MC lag is doing its job, we should not see a flap here. So the TISSU process is going to be pretty cool because I'll run the upgrade at the same time on both boxes. And we'll see if it can manage to upgrade both of them at the same time without actually having a fail event. The key here, though, the good takeaway is if you are running MC lag and you're running standard upgrade, then ISSU is just going to be an improvement on that. In any case, you should not lose any packets unless you try to lean into it like I'm doing, and that is trying to run them at the same time. So I'm going to pause this until the upgrade's complete, and then we'll check to see if we've lost any packets or if we've had any protocol convergence events. All right, all done. Took about 14 minutes and 30 seconds. Let's clear it. Let's check. Look at that, no flaps. We'll stop our test over here. We can see that we've got 13,348 packets. 13,348 packets. Perfect. All right, great. So we didn't lose any multicast packets, which you can probably infer that these two pies did not lose communication through the MC lag and the intermediary switches. And we didn't have a protocol flap with BGP. I have to assume that that's probably the same for the OSPF as well. So you have neighbor detail. We can see that this has been, well, it does look like this, actually that's, look like that might have bounced. But we didn't lose any packets, so that's good. We'll take a little bit closer look at this at the next upgrade. So I already have staged the other device. So this is already ready to be rebooted. So I'm just going to go ahead and kick off my multicast. And we'll do a request system reboot in. Yes, and this should just go right away. So I will clear this. It should take about 15 minutes again. We'll say yes. Oh, that's funny. It doesn't. All right, I'll spare you again. We'll come back when it's finished. Just a quick interjection. I was looking at why our adjacency flapped, and we can see that it's because the interface went down. So even though we do have MC lag, there is a, oh, there goes the reboot. There is a flip that happens when the active MC lag member goes down, and that is the active path for a peering session. So we didn't lose any forwarding packets, but we saw the interface go down. BGP didn't go down because BGP's peering loopback to loopback. So this is a very quick flap, and the recovery was fast as well. So I think the hit is pretty minimal, but there was a small OSPF hit. So we'll see if we see the same thing when we do the ISSU. All right, we'll wait 14 so minutes and I'll be back. Right, took almost exactly the same amount of time, which you would expect, but still, you kind of go into these things and you're like, it's not going to be exactly the same amount of time. Sure enough. Right, I'll get logged into, this is QFX SW2. Oh, lab password. Go ahead and write it down. I don't use it anywhere else. Clear, CLI, show version. All right, we're where we need to be. And we can see here that our OSPF has not flapped, because in this case, the interface that's active, which is SW1, and that's just sticky because of the configuration on this box, that when both nodes are available, the SW1 is the primary node. So even if there's a failover event, it'll come back when it's back up. So OSPF didn't go down. I'm sure BGP didn't go down. We'll go ahead and stop our packets here, 77, that's 60, and 7760. Perfect. So we didn't lose any host traffic, and we didn't see an OSPF flap. When we did the primary, we saw OSPF bounce because the interface went down, but BGP stayed up and traffic forwarding was not impacted. So that wraps up this upgrade. Now we're going to do the next one. So what I'm going to do now is pause once again and copy the upgrade files on. We're going to be going to 20.2 R2S1, and we should be able to use the ISSU process on this. It'll be TISSU by virtue of us having graceful switchover, non-stop routing, non-stop bridging enabled. And I'll run the upgrade at the same time on both devices. And I don't think you would ever do this in production, but I want to see what happens. So we'll give it a shot. I'll be back once the code's copied. All right, here we go. Here's the setup. I've got OSPF being monitored on EXSW1. I'm going to monitor BGP on EXSW2. I've got my in-service upgrade commands almost complete here. I did add var temp. Just didn't want to push the command off the screen when I did autofill on that. And I've got this one staged as well. So I'm going to run these at roughly the same time as I can. So the first step here, we'll get this listening, and we'll get this sending. And geez, we'll drop the hammer. Here we go. All right. I am going to pause unless something really interesting happens. And I guess I should make sure that that passed. We'll see how this goes. I'll be back. Let me start this timer. I'll be back when it's done. See you soon. All right, so about 19 minutes. I hit enter a few times. You can see up here where the actual flip happened. It did all the failover prep. So what it did here is it upgraded the secondary host, and it's done the switchover now. So I can actually log into this device. And you can see here that the code has been updated. And that should be the same for this other device here. That's cool. That is so cool. OSPF stayed up. I'll go ahead and stop that. This is an hour, not a minute, so that has been up for an hour. Did not flap during that process. I'll go ahead and stop the timer as well. I don't expect to see that BGP flapped either. No flaps on BGP, so let's go ahead and stop this and look at that. Same number of packets. Brilliant. And that was running the upgrade at exactly the same time on both of the devices. So that seems successful to me. I'm going to go ahead and stop the video here. If you have any questions, put them in the comments below. This is kind of a long one, so I'll put some timestamps in the description. I might be able to edit it down a little bit. It's sitting at about 23 minutes right now. Thanks for joining me. If you have any questions or want to see anything, this channel is driven by those types of requests and people asking to see, have something explained or see something in work. Ask it. That's how I get my content. So have a great day, and I'll see you in the next video.